Happy to be here and talk a little bit more about how you can help your teams deploy serverless services with full confidence. What is serverless? As Alon was saying, serverless are these technologies that allow you to run workflows on demand without any concern for the underlying infrastructure. This means that your teams can simplify operations and spend more time focusing on your customers. Lambda here is the most popular serverless technology in AWS. As you can see, when you deploy your code, the literal definition of the function in the AWS Lambda console is the code that you're seeing at the bottom of the screen. I saw you all raise your hands up. A number of you are already using serverless. And even within Datadog, when we look at usage of serverless across organizations, we see that serverless functions are widely adopted in each cloud. Not just in AWS, but also Azure Functions and Google Cloud Functions. At least 1 in 5 organizations are using these technologies. But as you might know, well, serverless applications are more than just functions and require more than just Lambda, unless your use case is scheduling cron jobs. You're going to need more than just Lambda functions in order to do more complex workflows that can help your customers. First, if you want to connect your Lambda functions to the web, well, you're going to need these fully managed API technologies like API Gateway and AppSync. If you want to do some sort of asynchronous processing or some batch processing in your Lambda functions, well, you're going to need to split up that logic a little bit and link them with some event streaming systems like SNS, EventBridge, and SQS, or even Kinesis, which will stream messages from one Lambda to another and scale alongside. If you want to persist data, well, then you're going to need some managed data stores, things like Dynamo or S3. So if you're migrating from monoliths or microservice-based architectures, a simple service might turn into multiple Lambda functions, these managed APIs, event streaming systems, and data stores. So this promise of serverless of like observability and of all the benefits you get there, well, you need to be able to not only monitor the functions, but also all these other systems in your applications, because these are also failure points for your requests. And at scale, this becomes even more important, because you don't just have one service, you have multiple, you potentially have hundreds. And for all the benefits of these functions, it's hard to get a global view of your ecosystem. And this is the same is true in other clouds like Azure and Google. And if we look at usage of Lambda functions today and how they're used alongside other technologies, yes, API Gateway is responsible for over half of all Lambda invocations, but there's a super long tail of fully managed technologies that are used alongside Lambda in order to power your processes. So it's even more important to have visibility into all these systems. So how can you take responsibility and ownership this time for your serverless services? How do you make sure that you are able to detect issues in real time across all the technologies we just saw? How can you quickly identify root causes of those issues? And then finally, how can you make sure that you're taking quick action and remediating and making sure that your systems are going back to being healthy? So I'm going to go do a quick overview of a number of new features in the serverless monitoring product that help you do just this and that we worked with our customers to come up with. The first is around detecting issues and making sure that you can see all of your serverless resources in one place. There you go. So what you're looking at here is an inventory of all your serverless services. And not only are you able to see your Lambda function metrics here, but also metrics from API Gateway and SQS, and even more. And you're not just seeing like unrelated Lambda functions next to one another. You're seeing these grouped in ways that are logical. So by service, by team, by AWS account, or really anything that works in your organization. And not only is this helpful for getting a really good sense of the health of your environments at scale, but it's also really useful for getting understanding where you need to set up alerting in your services, where are all the different gateways and SQS queues that can go wrong, and where do I need to make sure I have coverage. So that leads me to my second point. How can you get a real-time alerting for some of these technologies that are fully managed and typically a little bit harder to observe? The key to that is to use application performance monitoring, or Datadog APM. And traditionally, when we think of APM, we think of these distributed traces which collect requests and tell you how much time requests are spent in each service as it flows through some distributed application. And I'll talk about that in a minute. But APM is also really useful for generating real-time statistics for these technologies that are typically very hard to observe. So in this case, what you're looking at on the screen is a metric from an SQS queue of its latency or the lag in the queue as it's being backed up and can't invoke the downstream Lambda function. And this is the view that you would see when you get alerted to that fact in Microsoft Teams or Slack, and you're brought to this page, and then you can see really quickly from that metric, you can click on it and then pivot to the related traces that will exhibit the behavior of increased latency or errors. So what we've covered so far is some new tooling that helps you detect issues in your environments really quickly. Now, when you're brought to those traces, how can we make sure that we're helping you identify root cause? What you're looking at now is a distributed trace that starts from the front-end browser, the user's session, goes through a Rails app, and then invokes a serverless application, starting with API Gateway, Lambda, SQS queues, and more. We're able to see right off the bat that the user isn't impacted by this issue, and we're even able to see the stack trace, or the error of the Lambda function, giving you a quick sense right away of what might be going wrong in your system, and already knowing that in the browser, users aren't seeing issues. This is really useful as a starting point to be able to see the error, jump to related logs, and see all these metrics from, let's say, the Lambda functions and how they're performing. But what if this Lambda function is only failing 1% or 5% of the time? How do you get a sense of what types of patterns in event payloads are causing this Lambda function to fail? Well, for that, we now collect event payloads for each Lambda invocation. So let me show you a little bit what that means. If we're looking at the same trace and this Lambda function that's failing for this given invocation, we can actually see here the corresponding event payload for that failing invocation. So what that means is right off the bat, you can see potentially which customers were impacted by this. You can do a backfill afterwards. You can see which fields in your event payload are potentially don't look right and might be causing your Lambda function to fail. And you can use this content to reproduce the issue locally, helping you better understand or step through your code to understand what's going wrong. So these tools combined give you a really good understanding of not only how to detect issues, but from one place, this distributed trace, see the root cause, the error, and all those things. So from that, how can you quickly take action on these things? Something I'm excited to share is being able to pivot to the related GitHub commits for these functions in Go and Java, and soon to be more runtimes. So I can explain a little bit what that means from this distributed trace of a Lambda function. Yes, we see the error at the top, but we also now see a button that lets you pivot to the related function code in GitHub, and even that code embedded into the Datadog app here. And this is super important so that your teams can get aligned and quickly get a mutual understanding of what might be going wrong in your function, and then so that you can pivot to your function code in GitHub to see the commit and the when and why of this issue being introduced. So how does this all work? At Datadog, we've been partnering with Amazon mutual customers since they started building up Serverless to provide this kind of first-class visibility into these serverless technologies. The result of that is what you see on the screen called Lambda Extensions. Lambda Extensions not only allow you to get visibility into some of the code running into the Lambda functions, but much as I showed you here, they provide really valuable context into the resources running alongside Lambda in real time and with minimal latency overhead. This is because Lambda extensions run as a separate process outside of your Lambda function code, meaning we can send telemetry and generate telemetry data for the processes running in your function without impacting the response latency of those invocations. And of course, all of this works without any code changes, meaning you can roll out these extensions and Lambda layers without requiring to actually modify the application code of your functions, meaning you can roll this out across larger organizations. So this is a quick overview of the recommendations when me and my teams are working with serverless customers, how we recommend they take responsibility for the serverless services. So how they can quickly detect issues, identify the root causes of those issues, and take action and remediate on those. If this is something that's interesting to you or you want to talk about this more or any serverless technology more, there is a serverless open space at 4:15 p.m. So I'm happy, and I'm sure other people in this room will be happy to hear more about your use cases. Thank you.